Hey everybody, today we're going to be talking about LRFD loading systems. And LRFD, for any of you who don't know, is load and resistance factor design, which is one of the more common methodologies for analyzing the loading systems on structures and factoring them so that you get a proper design load with a proper level of safety. So we have 5 different equations for LRFD loading. Some things to point out. You're going to see that some of these are listed in groups where you are going to have what's called a controlling factor, and we'll talk about that in a second. You're also going to notice 5 different equations where the factors out in front of the different types of loading are often different. Sometimes they're similar, as in equations 2, 3, and 4 with the dead loading that you see here, the factor there. But also equations 1 and 5 demonstrate different factors for loading. So it's important to be paying attention and make sure that you're properly utilizing the equations. So what is a controlling factor in these designs? When we're talking about controlling factors, we're going to see LR or S or R, which are 3 different types of roof loading or loading in general that could be experienced by a building. We are talking about LR, which is live roof. We have snow loading, and we also have rain loading. So let's say we have all 3 of these on a building, and say the live roof load is 30 pounds, the snow load is 50 pounds, and the rain load is 40 pounds. Now, realistically, the reason that we're calling this OR in here, instead of saying AND, or having a separate factor for each of them, is we're looking at the probability of multiple of these things happening at the exact same time. Now, live roof loads specifically, where I say all these are in PSF, by the way, are often attributed to people going up on the roof to do maintenance or any sort of other task. Snow and rain can also be considered in the family of live loading for a building. So really, when we're looking at this, we're only expecting one of these to be happening at the same time, right? Because you're not going to have snow and rain at the same time. And if you have snow or rain, you're probably not going to have any sort of maintenance personnel up on the roof or any sort of temporary equipment up there, because it would be uncomfortable to work or it could damage the equipment that's up there. So we're just going to look for the controlling factor, and in this case, since snow is the highest, that would count as our controlling factor for this design. So let's look at an example problem. A roof is carrying the following loads: dead load of 30 psf, live load of 30 psf, snow load of 100 psf, and a wind load of 60 psf. Notice the arrow that I have drawn here to indicate that the wind is going in the upward direction. We'll talk about what that means in a little bit here. So determine the appropriate load case and the factored loading. So we have our 5 equations written down here. We're just going to go through them and we're going to see what we come up with. 1.4 dead is going to be 1.4 times 30, which if we pull out our calculators and we look at it, we have 1.4 times 30 is 42 psf. Relatively low, but let's see what our other equations give us. 1.2 times our dead load plus 1.6 times our live load. Now, before I go through this, let's look at this fact that we have a live roof load here and we have a live load. These are different, okay? So when we're talking about a live roof load, L is not equal to LR. In this case, since it says it's a roof, we know that we're talking about a live roof load here. But a floor load is slightly different because of how it interacts with other parts of the building. You're normally not going to see both of them in the same problem if you're talking about either a floor loading plan or you're talking about a roof loading plan, because live load that's on a roof will always be a roof live load. And if you're in a interior floor of a building, you're not going to have a roof live load because you're not on a roof. Where it does matter is when we come into column design and we're talking about carrying loads from multiple floors and the roof. So right now we can say that our live load is actually 0 here. And then we get into this controlling factor that we were talking about. So let's look at our loads. We have a live roof load of 30 pounds per square foot and a snow load of 100 pounds per square foot. Well, the snow is bigger and we don't have a rain factor. So we're going to put in 100 here because that is the controlling load. 1.2 times 30 plus 0.5 times 100 is 86 psf. So now that's higher, so it will control over case 1. But let's see what the rest of our equations yield us. 1.2 times 30 plus 1.6. Now we come back to the same 3 where we have to choose, and it's going to be snow again. And then we have one more. So now we get to look at which one of these is higher. We have 0.5 live load or 0.5 wind load. Okay, now that's a little different. That's kind of interesting to look at. So when we're looking at this, we don't have a live load, so we know wind is going to control. So we're going to say plus 0.5 times 60, right? Well, not quite. I indicated the arrow here and pointed it out to indicate that we have what's called uplift here. The wind pressure on the building is actually creating a sort of vacuum over the top of the building, and that wind load is actually going to act in the opposite direction of the gravity loads that are on the building. So when we're looking at this is actually a negative 60. It's going to detract from the total loading on that. So if we go into our calculator here, add all these up, we have 0.5 times 60. And we are going to get 166 PSF. So two more here, 1.2 times 30, plus 1.0 times, remember, negative, plus 1.0 times 0, plus 0.5 times 100 now. Here we're going to get 1.2 times 30 minus 1.0 times 60 plus 0.5 times 100. We're going to get 26 PSF, very low. And then this last case, you can probably tell this isn't going to be our governing case. We have 0.9 times 30 plus 1.0 times negative 60. It's interesting here because we're actually, if this case were to govern, we would have a negative pressure, but that's not what's going to happen. So 1.0 times 60 is going to be negative 33 PSF. So if we come back here, let's write in let's write in green what we're going to be dealing with. Case 3 was our highest. So case 3 governs. And the load is 166 pounds per square feet. So this was a very basic roof loading problem for the LRFD design methodology. I hope you guys found this helpful, and stay tuned for other videos coming in the future. Hope this helped.